Alright, problem number 2. Not sure how tired I sounded in that last video, but we're going to give this one a go. We have a polynomial fourth degree function. We're told it has a 0 of multiplicity 2 at x equals 2. First off, remember that having a 0 is the same as being a solution. And we should know by this point that if we have a solution to a polynomial, then you can write that solution as a factor, x minus whatever the solution is. And our solution is 2. Our 0 is at x equals 2. So our factor is x minus 2. But we are told that it is a multiplicity 2, which means that that factor is squared. So two options here. You could either expand that x minus 2 and get x squared minus 4x plus 4, and then you could do a long division once. Or, if you're like me, you're going to do synthetic division twice, because it's a lot quicker and easier to do than long division. So let's set up our synthetic division problem. In this little half of a square thingy-mabobber, we put a positive 2. We put whatever the solution is. So we started with the solution of x equals 2, and that is what we will be using in our synthetic division. And now we have to list the coefficients. So on the x to the fourth term, I have a negative 1, and then a positive 5, a negative 2, a negative 20, and a positive 24. First step is bringing that negative 1 down, and now we just multiply and add over and over again. So 2 times negative 1 is negative 2. 5 plus negative 2 is positive 3. 2 times 3 is 6. Negative 2 plus 6 is positive 4. 2 times 4 is 8. Negative 20 plus 8 is negative 12. And 2 times negative 12 is negative 24. And now we're happy because 24 plus negative 24 is 0, and that is our remainder. And if x minus 2 really is a factor, if x equals 2 really is a solution, then we should get no remainder when we do our division, because it should come out evenly. And it did. So now we can do synthetic division again, because it is multiplicity 2. So I'm going to use that result and divide again. So draw that bar, bring down that minus 1. 2 times negative 1 is negative 2. 3 plus negative 2 is 1. 1 times 2 is 2. 4 plus 2 is 6. And 2 times 6 is 12, which again makes us happy because negative 12 plus 12 is 0. And again, that 0 is my remainder. The last term is always your remainder. And now, negative 1, 1, 6 is telling us a polynomial. It is telling us negative x squared plus x plus 6. It is building up by a power of x as you move from the right to the left. So the 6 is a constant term, degree 0. The 1 is the coefficient on your x term, degree 1. And the negative 1 is the coefficient on your x squared term, degree 2. You're building up by a degree each time. Well, we can factor this. I'm going to pull that negative out, and we'll have negative x squared minus x minus 6, which still can factor. So negative x something, x something. What are those somethings? Well, somethings have to be minus 3 and positive 2, because we have to multiply to negative 6 and we have to add to negative 1, the coefficient on that middle term. Now, we've done our division, but the problem did not say, hey, do some division. The problem said, write f of x in factored form and sketch its graph. And f of x is this original equation, which is a fourth degree function. So if you say that f of x equals that, negative x minus 3, x plus 2, you would be incorrect, because it totally doesn't. It also has an x minus 2 factor of multiplicity 2. That is f of x. You cannot forget about the thing you just divided out. So there we have f of x totally factored, and it says to sketch its graph, label all x-intercepts and the y-intercepts. So let's draw some axes here for our graph. Let's find all our x-intercepts. Well, they're going to be at 2, negative 2, and positive 3. So let's go 1, 2, 1, 2, and a positive 3, and we can plot all those zeros right there. Let's think about where our y-intercept is going to be. Well, look at the original equation, totally expanded. 24 right there, no x term, constant term. That has to be our y-intercept. So I know it's going to be positive and up here. Well, don't really have any choice in the matter. Going to have to kind of come down to that 0, go down to that 0. I don't know that that 24 is a maximum value, but I do know that it does have to go down to those zeros because you have to hit those zeros. Do I cross or do I bounce at those zeros? Well, when x is 2, I have a 0 of multiplicity 2, so I have to bounce at this 0 right here. Boom, I have to bounce, go back up, and turn, and I have to hit that 0, and I have to cross because it's a multiplicity 1. I also have to cross at this 0 because it is a multiplicity 1. I can label that as 0, 24. The tick marks show me where my zeros are, and we have our graph. That agrees with our end behavior because it is a fourth degree function and it is negative leading coefficient, so both tails should be down just like negative x squared. And that's it.